Okay, so hi everyone. In this video, we're going to be going over the 6 trig identities and also other identities, as well as some examples. So, let me go ahead and rewrite it. Okay, so, one identity is going to be, so if we look at our notebook here, or at our textbook, we have our reciprocal identities. So first is try to write that, reciprocal identities. Let me make the screen a little bit bigger, or the notebook a little bit bigger so that I can write better. So it's gonna be 6 trig identities. And so our first identity is going to be sine of theta equals 1 over cosecant of theta. That's for our first identity. And so then after that we have cosine of theta equals 1 over, it's going to be cosine of theta equals 1 over secant of theta, and then we have tangent of theta equals 1 over cotangent theta. Actually, I'll go with the smaller screen so that, or the smaller, no, the smaller, so, then we would say, so we had cosecant, or we had sine of theta equals 1 over cosecant of theta, and then we had cosine of theta equals 1 over secant of theta, and then we had tangent of theta equals 1 over cotangent of theta. And so basically from there we would say, so then we would say, we would do for the other functions. So we would say cosecant of theta equals 1 over sine of theta, and then we would say secant of theta equals 1 over cosine of theta, and then we would say that cotangent of theta equals 1 over tangent of theta. So then those are for the 6 I would call these reciprocal identities. So these are the reciprocal identities that you would use. And then there are other ones as well. So you have your I believe they're called even and odd identities. I'm not really sure, but there's one that says tangent of theta equals sine of theta over cosine of theta. And then there's the other one that says cotangent of theta equals cosine of theta over sine of theta. And then you would have your Pythagorean identities, which are I'm gonna write with the pen better because I feel like with the pen it's more easier. The reason why I wasn't gonna write with the pen was because I didn't want to waste my lead on it, but it's fine. Anyways, so we have our Pythagorean identities, and the first one is going to be sine squared of theta plus cosine squared of theta equals 1. And then we also have, let's see, we have, that's 1, and then we have 1 plus tangent squared of theta equals secant squared of theta, I think. And then we have 1 plus cotangent squared of theta equals cosecant squared of theta. So then, okay, so we already have all the important identities. Oh yeah, these are your quotient identities, by the way. These would be these two, so let me rewrite them. So these two would be your quotient identities. And okay, so now we're actually gonna go ahead and try to see if so we're gonna go over some examples. I'm not gonna do the ones that are on the examples, just because I mean, I don't think it's necessary. You can actually see what is going on there. But we're actually gonna do some examples that are more like some of these, for example. So let's see. Okay, so we have, let's do number 27. So number 27 says, so for exercises 27 to 32, it says use the given function values and trigonometric identities using the cofunction identities to find the indicated, including the cofunction identities to find the indicated trigonometric functions. So let's see. We have sine of 60 degrees equals the square root of 3 over 2. So if we actually draw a triangle, I'm going to go ahead and try to draw a triangle. And we have, let's say that here's our 60 degrees. And we have that 60 degree, that sine of 60 degrees equals the square root of 3 over 2. So if we remember from our SOHCAHTOA, we can say that this is going to be our opposite, and this is going to be our hypotenuse. So basically, we can say that this is going to be the square root of 3, and this is going to be 2. And it's asking us to find, oh yeah, and it also says that cosine of 60 degrees is 1 over 2. So cosine of 60 degrees, let me write that, equals 1/2. And we can say that this is adjacent, and this is hypotenuse. So, so now we know our third side, it's 1. So the way that I would do this is, so the first one is asking what's tangent of 60 degrees. So tangent of 60 degrees, you can go ahead and treat this as if it were like a tangent of theta problem, you know? So it's the exact same thing that you would do for, you know, for a, for a type of, you know, for when you don't have a specific degree value. The reason why they use these numbers right here is because this corresponds to the unit circle. So the reason why they use like the square root of 3 and then 1 and then 2 is because this corresponds to the unit circle, and it's not just because, you know, 1 squared plus the square root of 3 squared equals 2 squared. So, yeah, I just wanted to point that out. So tangent of 60 degrees is going to be opposite over adjacent. And if you know how to, you know, label your sides, I'm going to go through that again. You would look at your 60 degrees and you would say, what's opposite of that? Well, it's the square root of 3. And adjacent just means next to. So next to 60 degrees is 1. So this would be your adjacent side. And so you would say, tangent of 60 degrees is going to be the square root of 3 over 1. So it's going to be the square root of 3. And then it's asking, what's sine of 30 degrees? So now we're involving 30 degrees on here. So part B, this is part A. Part B is asking what's sine of 30 degrees. So sine of 30 degrees would be, so you would look at your triangle again, and you would say it would be opposite over hypotenuse, so you would say 1/2, and that would be your sine of 30 degrees. And let's see. And then part C is asking what's cosine of 30 degrees? Well, cosine of 30 degrees, if you look at your triangle again, you would do adjacent over hypotenuse. So you would say that the cosine of 30 degrees, if you, so you would do adjacent over hypotenuse. So you would do adjacent. This would be your adjacent side, and this would be your hypotenuse. So you would say the square root of 3 over 2 for that one. And then part D is asking cotangent of 60 degrees. So we have part D is asking for cotangent of 60 degrees. And so you would basically do, if you know this term, would do cotangent of 60 degrees would be, so this would be opposite, this would be hypotenuse, and this would be adjacent. So if you want to look at cotangent, you would do, so this first part would be cosecant of theta, the second part would be secant of theta, and this third part would be cotangent of theta. So just knowing at what this part is, you would say adjacent over opposite. Or if you want to just think of this as the reciprocal of tangent, you know, you can say adjacent over opposite, just switch them up. And so you would say 1 over the square root of 3. And if you want to, if they ask you to rationalize the denominator, I know in my pre-cal class she didn't ask us to do that, but it's always safe to do it. It's always better to do it than just in case they ask for it. You would get cotangent of 60 degrees equals the square root of 3 over 3. Okay, so and I didn't do these first few parts because I mean, it seems pretty straightforward. For this part, you just have to, you'd have to know your unit circle. Or you have to look at the unit circle and know what what degrees correspond to what function value, and how to turn those degrees into radians and those radians to degrees. So it's pretty straightforward. Okay, so for this next part, I'm gonna try to do most of them, if not all of them, just so, because I know for me, these were actually really difficult to understand, and these trig identities were really hard to understand, and so I would actually do, I'm gonna actually do a few of them just so that you guys can kind of understand how it goes. But yeah, let's get started. So the first one is saying tangent of theta times a cotangent of theta equals 1. So if you know, one of the things that I recommend that people do for trig identities is to memorize them. I know I had to memorize them myself, and I mean, I know for some people it's hard to memorize, and for me it was hard to memorize, but as long as, one way to memorize them is to just keep practicing with them and having the actual, like a cheat sheet with you, just to know how to do it. So since we went over the trig identities up here, we can apply them over here. So for this one, we can do, so one of the things that I recommend is, one, turn your so turn your terms into sine and cosine if they're not already. So for this one, it's not in terms of sine and cosine. So we already know what tangent of theta is. It's going to be sine of theta over cosine of theta. And we would basically turn this part too into cosine of theta over sine of theta, because again, when we went over trig identities earlier in this video, I said that cotangent of theta equals cosine over sine. So you would basically cross multiply, this cancels out, this cancels out, this cancels out, and this cancels out, and you're just left with 1. So basically it's just 1 times 1, which is 1, and you verified it. Number 34, let's see number 34. So it's kind of the same thing, cosine of theta, secant of theta equals 1. So we know cosine of theta, we can't do anything with that because it's already in terms of sine and cosine. And then secant of theta, well, if you remember from earlier what secant of theta is, you would do secant of theta equals 1 over cosine of theta, and so you would apply it over here. It's being multiplied, so it would be cosine of theta over cosine of theta, which is equal to 1, and that equals 1. So you verified it. And then 35, let's see 35. We have tangent of alpha times the cosine of alpha equals sine of alpha. So we would say sine of alpha over the cosine of alpha times the cosine of alpha equals sine of alpha. And you would finally say sine of alpha equals sine of alpha. And you verified it. Number 36. We have cotangent of alpha times sine of alpha equals cosine of alpha. So we would say, remember that cotangent of alpha would be cosine of alpha over sine of alpha. And so you would say cosine of alpha over sine of alpha times the sine of alpha equals cosine of alpha. And you would cross these two out, leaving you with cosine of alpha equals cosine of alpha, and you verified it. And so number 37 says 1 plus cosine of theta times 1 minus cosine of theta equals sine squared of theta. So we would do 1 plus cosine of theta times 1 minus cosine of theta equals 1 minus, or it would be the cosine my bad. It would be sine squared of theta. My bad. So you would do the if you know how to do like a plus b times a minus b, it's just gonna be a squared minus b squared. So you would have 1 minus cosine squared of theta equals sine squared of theta, and you've already verified it because that's what it equals to. Sine squared of theta equals sine squared of theta. And then for number 38, it says it's kind of the same thing. 1 plus sine of theta times 1 minus sine of theta equals 1 minus sine, or equals cosine squared of theta. So again, this would be the same thing as here. You would say 1 minus sine squared of theta is equal to cosine squared of theta. So then cosine squared of theta equals cosine squared of theta. Okay, so the next one says, number 39 says, secant of theta plus tangent of theta times secant of theta minus tangent of theta equals 1. So you can do it two ways. You can either do like, you can either simplify it in terms of sine and cosine, or you can also do the same thing that I did up here, and basically, FOIL it out and find out what it is. So I'm gonna do it with the FOIL method. So it's gonna be secant squared of theta minus tangent squared of theta equals 1, because the middle term cancels out. So you would then say 1 over cosine squared of theta minus sine squared of theta over cosine squared of theta equals 1. And so then you would say 1 minus sine squared of theta over cosine squared of theta equals 1. And then you would say cosine squared of theta over cosine squared of theta equals 1, and 1 equals 1. So you verified it. Okay, so and then for this one, it's saying for number 40, it's saying sine squared of theta minus cosine squared of theta. So 40, it's saying sine squared of theta minus cosine squared of theta equals 2 sine squared of theta minus 1. So the way you would do it is you would try to get the terms into sine of theta. So you would basically say sine squared of theta minus parentheses 1 minus sine squared of theta equals 2 sine squared of theta minus 1. Another tip I wanted to give about trig identities is always keep one side, and it's mostly the right side, the same. That's one tip I want to give. And so you would say, so then for this one you would say sine squared of theta minus 1 minus sine squared of theta equals, or plus sine squared of theta, excuse me, equals 2 sine squared of theta minus 1. And so you would have sine squared of theta plus sine squared of theta minus 1 equals 2 sine squared of theta minus 1. And you would say 2 sine squared of theta minus 1 equals 2 sine squared of theta minus 1. And you verified it. Okay, and then for number 41, it says sine of theta over cosine of theta. So sine of theta over cosine of theta plus cosine of theta over sine of theta equals cosecant of theta times secant of theta. And one thing I would want to do if I were doing this problem first is making sure, so rewriting it, but making sure that I get this in terms of sine and cosine. So we say that cosecant of theta equals 1 over sine of theta times 1 over cosine of theta. So then we would say sine of theta over cosine of theta plus cosine of theta over sine of theta equals 1 over sine of theta times 1 over cosine of theta. So one of the things that you need to do in this part right here is you need to make sure that you get your terms, your denominators the same. So one way I'd like to do it is by actually adding it myself, so working it out myself in a separate part. And we know that in order to get the denominators the same, I would have to multiply sine of theta and cosine of theta, because there's no other, there's no other denominator that can, there's no other way that the denominator can be the same. So I would say sine of theta, cosine of theta on both terms, and so then you would ask yourself, how did I get from sine of theta to sine theta cosine theta? Well, you multiplied times cosine theta, and what you do to the bottom you have to do to the top. So you would also say times cosine of theta right here. So you would say cosine squared of theta, and then you would do times sine of theta, and then you would do times sine of theta right here, and then you would do sine squared of theta, and then lastly you would get sine squared of theta plus cosine squared of theta over sine of theta cosine of theta is equal to 1 over sine theta cosine theta. And we all know that sine squared of theta plus cosine squared of theta equals 1. So you would then say 1 over sine of theta cosine theta equals 1 over sine theta cosine theta. And you've verified it. And then for the last one, we would do, so for the last one, it says tangent of beta. I'm gonna go ahead and change the, to tangent of x instead. So tangent of x plus cotangent x over tangent x equals, let's see, cosecant x. So again, what you want to do is make sure you have your terms and you have each side in terms of sine and cosine. So I would say sine of x over cosine of x plus cosine of x over sine of x over sine of x over cosine of x is equal to 1 over sine of x. So first you want to do it step by step. So you want to take this step by step. So you first want to do this part. So since we already did this part in the last problem, you don't have to actually do it again. So what I got for that part was 1 over sine x cosine x, and then you would divide that by sine of x over cosine of x is equal to 1 over sine of x. And that's just a little shortcut, just because I know in the last one we did it right here. And so basically you would go ahead and say, so this is exactly like saying 1 over sine of x cosine of x divided by sine of x over cosine of x is equal to 1 over sine of x. And so then you would use your rule that, you know, that says a over b divided by b over c, or divided by c over d, equals a over b times d over c. So you would do 1 over sine of x cosine of x times cosine of x over sine of x. It's equal to 1 over sine of x. And then you would say cosine of x over sine squared of x cosine of x equals 1 over sine of x. If you're wondering how I'm going to get this to equal 1 over sine of x, just keep watching. So one way that you can do it is, so let's see. So let's see. I'm gonna try to see if I can do it. So we have cosine of x over 1 minus cosine squared of x times cosine of x but then again that wouldn't work. So we can go ahead and say 1 over sine of x times 1 over sine of x times cosine of x over sine of x So then you would say, bear with me guys, I'm kind of trying to figure this out because I know that I kind of made a mistake, or maybe I might have made a mistake. So we would do 1 over sine of x times the cosine of x over sine of x I'm wondering if I can do so oh man, this one's complicated. Oh, it's this cosecant squared of x. Okay. So let me go ahead and just erase what I did. I'm sorry guys, oh my goodness. This one really threw me off. So okay, so equals cosecant squared of x. Okay. I'm so sorry, guys. Oh my goodness. That one kind of threw me off. So, okay, so let's just do it again. So we have sine of x over cosine of x plus cosine of x over sine of x over sine of x over cosine of x equals 1 over sine squared of x. So we know from here, again, like I was saying earlier, we know from here that we're going to have 1 over sine of x cosine of x. So we have 1 over sine of x cosine of x divided by sine of x over cosine of x equals 1 over sine squared of x. So then we would do 1 over sine of x cosine of x times cosine of x over sine of x is equal to 1 over sine squared of x. And so then we'd have cosine of x over sine squared of x cosine of x is equal to 1 over sine squared of x. And then we'd cross that part out, and we'd have 1 over sine squared of x equals 1 over sine squared of x. I am so sorry, guys. Forgive me. I hope that this kind of helped. I know this one was... It was a mistake on my part since I didn't copy it right. But other than that, I hope that this kind of helps with trig identities if you're having trouble doing them. And if you have any questions, please, please comment down below, like and subscribe, and then I'll see you in the next video. Thank you so much for watching, and yes, I'll see you in the next video. Bye, guys.